guys, Mrs. Traver here. Today we're going to talk about properties of proofs. In this learning target, we'll be able to recognize quadrilaterals based on qualities and side length, slope, and angles, and you'll use proofs to do that. Let's jump in, and the first one I want to mention is the reflexive property of equality. The reflexive property of equality states that the measure of any side or angle is equal to itself. I always think about if you were flexing in front of the mirror, you're looking back at yourself. So for example, in this parallelogram, side BD, which is in both triangles, is congruent to itself. We can mark it like that. So if I was going to try to prove these triangles were congruent, one of my ideas could be that BD is congruent to BD is congruent to DB, and we could show that by the reflexive property of equality. Another one is the transitive property. It says if x equals y and y equals x, then x must equal z. So if, for example, 1 over 1 equals, let's do 2 over 2 equals 1, and 1 equals 3 over 3, then 2 over 2 must equal 3 over 3. That was kind of confusing with fractions, but you can make one thing equal to the next. Last one I'm going to mention is the substitution property of equality. If x equals y and x equals z, then y and z are also equal. So these are all kind of like obvious, but we need to put a reason for things when we do proofs, and these are the reasons we can use. The last thing I want to mention is a reason called cpctc. It stands for something. It's an acronym. So what it stands for is that congruent parts of congruent triangles are congruent. So what I mean by that is if you've already shown that two triangles are congruent, then all of their parts are congruent. So say maybe you proved something was congruent by side, side, side. You now know all the angles are also congruent. So after you've proved side, side, side congruence, you can then say, oh, and this angle are congruent. Why? Well, because congruent parts of congruent triangles are congruent. You'll see these as we go into the proofs. Here's a proof I'd like to do. We're going to do two of them today. Given triangle ABC and triangle CDA, prove that angle ABC is congruent to angle CDA. So when we start, we're going to do two-column proofs. The first thing we have is always something that was given. So let's see what we were given. We were given some markings in the picture, and it says that these two triangles, I want to try to prove ABC. So I want to try to prove, I'm going to put this in, that this angle B, ABC, is congruent to this angle CDA. So my idea is if I can prove that they are first congruent, then I could say, well, hey, those two angles must be congruent by congruent parts of congruent angles are congruent. So let's first prove that they are congruent. So let's see. If I'm going to do that, I'm either going to use side, angle, side, 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 angle, side, angle, 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 side, or RHS. We've got 5 options. And this one, I have angle, side, angle. So let's start with saying that our angles are congruent. I'm going to first do the single marked angle. That's angle BCA, which is congruent to the other single marked angle DAC. And my reason is that was given. Let's do the other angle while we're at it. We have angle BAC, which was double marked, is congruent to angle ACD. That was also given in our diagram. Lastly, I have side AC, which is congruent to itself. And this is, as we just learned, the reflexive property. So now that my two triangles are congruent, let's put that in triangle. I'll say ABC is congruent to triangle. So if I did 2 marks, no marks, 1 mark, 2 marks, no marks, 1 mark, I'll do CDA. And this is by side, angle, side congruency. Now I can finalize. I need one more row in this, sorry. I could finalize and say what I was trying to prove. Angle ABC is congruent to angle CDA because congruent parts of congruent triangles are congruent. That's my last reason. All right, that's it for today. You're going to see some more of these as we come into the next videos. I will see you then. Bye, guys.